Hi guys, how did chapter 5 go? Can't answer me, but I hope that it went well. Onward and upward, as they say. We have to just keep moving forward. This is chapter 6. Chapter 6 is factoring. We're going to be taking a look at all different types of factoring. We're going to be doing, let's see, GCFs and difference of squares and factor by grouping and two different trinomials. And then we'll be using it in solving and in our rational expressions. So we'll just take it slow. Each section, I think, has either one. This one might have two types. So we'll just take a look at each one individually. So this first one, well, let's first of all just talk about what factoring really is. All right. All right, let's just say that I had 2 times x squared plus 3x plus 7. Well, to simplify, I would be distributing this 2 in. I'd multiply each term by 2, so I would have 2x squared plus 6x plus 14. Okay? Well, factoring isn't going from multiplication to here, but it's taking this and going this way. So we're going to be taking these expressions and we're going to be taking out pieces. We're going to be breaking it into pieces. Another one that we are going to be seeing that's going to be very common is going to be ones that look like this. Okay, so we have x squared. I'm going to be foiling this. Minus 3x plus 2x minus 6. So we have x squared minus x minus 6. All right, again, this is, this first one here is a factoring GCF problem, and this one's a trinomial problem. So we're going to be taking an expression like that and turning it into that. Okay, so that's what factoring really is. It's just reversing multiplication, getting back to where we started. All right? So we have different types of factoring, and our first one is called GCF. Okay, as you can see up here, it stands for the greatest common factor. So let's talk about what a factor is. Okay. Factors are numbers that divide evenly, and that's the key word there, is evenly, into other numbers. So that's what a factor is. Well, let's take a look. What are my factors of 10, for instance? Well, what are the numbers that divide evenly into a 10? 1 does, 2 does, 5 does, and 10 does, right? For instance, 10 divided by 1 is 10, 10 divided by 2 is 5, 10 divided by 5 is 2, and 10 divided by 10 is 1. So 3 doesn't divide in evenly, right? We get what, 3 point something. Okay, so we don't get a nice whole number back out when we divide. So that's what my factors are. All right, so what I'm trying to do is I'm trying to look for the greatest common factor, the biggest number that's a factor for both of these at the same time. Okay, well, let's start by looking at the numbers here. We have a 24x and we have a 28, and we want to have the GCF between those two. Okay, so let's first of all take the numbers 24 and 28, and I want to ask, what is the biggest number that divides in evenly into both of those numbers? The biggest. Well, I look at those and I think, well, I know a 2 goes into both of those, right? But also a 4 goes into both of those. And a 4 is bigger, so I'm going to say the GCF here is a 4. All right? It's the biggest number that goes into a 24 and a 28 evenly at the same time. Now for variables, all right, so that's how you do numbers. I mean, obviously, there's other ways of doing these. When these get really large, we're gonna have to find a different method, because These I can eyeball. I can look at it and say it's a 4, but some of these numbers that are in here are huge, and there's no way that I can know that. So I'll have to find a different method. And I'll show you that as the numbers get larger. But for variables, we always take the lowest powered on similar bases. Okay, so here we have a base of an x. Here we have 1x, right? Here, let's do this. I can rewrite this as 24x to the first power and 28x to the 0 power. What is anything to the 0 power? Well, remind yourself, anything raised to the 0 power is 1. So this is 1. 1 times 28 is 28. So I can say that there is 0 x's on that. Okay, so my lowest power is 0. So I can't take any x's out of there. So my GCF on this one is just a 4. Okay? All right, so here we're starting to get some larger numbers. I look at that and I say, I really don't know what's in the 30, a 110, and a 60. Obviously the variables is 5. X to the 5th. That one's super easy. I just look at my powers. Between a 5, a 6, and a 9, 5 is the lowest. But the numbers are a lot harder. So what I'll do is I'll show you with trees. These are factorization trees, and I know we've done these before. And this is why we would do them. So I'm going to factor these out into its prime factorization. Okay? I'm going to start. What makes a 30 besides a 1 and a 30? Well, let's see, let's do 2 times 15, right? Remember, I'm going to break these down into their primes. This one's prime, this one's not. So this one I just drag down, and this one I'm going to split apart. We've got a 3 and a 5. All right, this one's finished, so I'm going to circle it. 2, 3, and 5 are all prime. I'm going to do it again. What makes a 110? Well, among other things, an 11 and a 10 make a 110. This one's prime, and this one's not, so I'll break that down into its prime numbers. 11, 2, and 5. 2, 5, and 11 are all prime. And then I'll do it again for 60. Okay, now, does it matter if I do 2 times 30 or if I do 6 times 10 or 3 times 20? No, it does not. Just pick any 2 and go from there. Okay? So I'll do 6 times 10. And both of these are not prime. A 6 is a 3 times 2, and a 10 is a 2 times 5. And then this one's done. All right, so I've circled these to say that these are my prime factorizations of my numbers. And now what I'm going to do is I'm going to go back through and I'm going to list my factors. What I'm doing is I'm saying, what kind of numbers do I have? What do I see? I see 2s. I see 3s. I see 5s. And I see 11s. Those are my different types of numbers within these 3 bubbles. Okay? Now to find my GCF. Greatest common factor. Right? What do these have in common? Okay, these are the ones that I'm looking for. Do they each have a 2 in there? Yep, they do. So I've got to have a 2, right? Does each one have a 3? No, this one doesn't have a 3 in it, so it can't be a factor. It can't be a common factor if this one doesn't have a 3 in it. What about 5s? Yep, we have a 5 here. Okay, so I want that. And what about an 11? No, that one doesn't have 11, that one doesn't have 11, so that's not common. Okay, so the GCF here is 10. It's the biggest number that goes into a 30, a 110, and an x to the 9th, and a 60 all at once. I'm looking at these numbers. Okay, I mean, obviously there's a 10 in there. I just didn't know if it was the biggest one. It has to be the largest. Okay, so here we're going to say our GCF is a 10. That's for our numbers. And then our variables, like I said, are very easy. We're just going to take the highest powered one, and that's the 5. Okay? So this is a method that if you can't see it, okay, which I have a hard time with higher numbers, seeing what is the common factor, the greatest common factor, then you're going to want to go through and do this tree thing, okay? It works every time. See, some of these numbers are enormous. Look at these numbers, you guys. Whoa! All right, so you're going to do it again. So, you know, when you're doing your GCF, just disregard these negatives. We're just going to do positives, all right? Because this has a -1 and this has a -1, but these don't, so that's not common. All right, should we do this one? Boy, those are some really enormous numbers. I cannot believe that. I think we should. We've got 4 of them besides. 330. What goes into a 330? Well, I know that a 33, I'm going to do a dot this time. I don't like those X's. The times symbol looks like that looks like an X to me. All right, so 33 times 10, and this is 3 times 11, and this is 2 times 5. So here we've hit all prime. So what we're doing is we're just breaking these things down into their component pieces to see what's in them. Now here I have a harder time looking at it and going, what's in a 198? Okay, so I'm going to just take the 2 out of there. Anytime that it ends in an even digit, we know that this is, you know, your last digit here, and it's even. 2 will go in there. So we have 2 and 99. Now I can see it better, right? This is prime, this is not, so I'm going to drag my 2 down so I don't lose it. This is 9 times 11, correct? And then this is the only one that's not prime yet. So these I'm going to drop down. So here I have 2 times 3 times 3 times 11. So you can kind of see right away that the 2, the 3, and the 11 are going to be common between just these two. The 5 is not, so the 5 is going to be out. I'm going to do it again with 726. Again, I don't know what's in there, so I'm just going to take the 2 out just to see. Sometimes it's so much easier just to drop it down. So here I have 2 times 363. Okay, prime. All right, 363. Well, I know a 3 goes in there because 3s, 6s, and 3s are all divisible by 3. And that goes in there 121 times, right? And then 121 is 11 times 11. Now, let's just, before we move forward, let's just do a quick check, okay? Let's just go back through and just multiply these out to make sure we've done them correctly. So 3 times 11 times 2 times 5. That should give me 330, okay? 2 times 3 times 3 times 11 will give me 198. And 2 times 3 times 11 times 11 should give me the 726. All right, so what I'm doing is I'm breaking these down, but I'm going to always go backwards to see have I done them correctly before moving forward. And lastly, we've got this 462. All right, again, I don't know what's in there, so I'm just going to pull the 2 out. 462 divided by 2. Boy, these are just ugly numbers. 231. Really ugly numbers. Okay, now if I add my digits, 2 plus 3 plus 1 is 6. 6 is divisible by 3, so this number is divisible by 3. There's a trick. Divided by 3. So I've got 3 times 77. So I've got 2 times 3 times 7 times 11, right? So again, I'll just do a quick check. 2 times 3 times 7 times 11. Especially in a test situation, you want to just double check to see if you've broken those down correctly. All right, what are my factors that I'm looking for? This is not the most critical piece of it, but it will be when we're looking for LCD. So I want to get used to listing our factors. We've got 2s, we've got 3s, we've got 5s, we've got 7s, and we've got 11s. So these are the ones that I'm going to be comparing. So my GCF, does each one have a 2 in it? Yep, I've got one of those. Now if each one had 2 2s in it, then I'd have to write down 2 of them down here. All right? So if each one had more than 1, you take the lowest one. All right, what about 3s? We got 3, we got 3, we got 3, we got 3. So I'm going to have a 3. That's common. 5s are not common. It's not in this one. 7s are not in this one. It's not in this one. It's not in that one. So 7s are definitely not common. But I see a 11, 11, 11, 11, and 11 in each one of those. Yes, I have 2 11s here, but I only have 1 there, 1 there, and 1 there. So now I'm going to take my my factors that are common and remultiply them. So 2 times 3 times 11 should be get 66. I'm just going to double check that. You know, don't be afraid to use your calculator for checking. Okay, so that's a number that goes into each one of these is 66. Now that one I for sure couldn't have seen. Okay, so we've got 66 here. Now we're going to go back through and we're going to look at our variables. How many A's do we have? We have 1, 1, none, and 1. So I can't have any. Now I'm going to go back through and take out my B's. I've got 3, none, 1, and 1. So I'm done there. Okay, I can't take out any A's and B's because this term doesn't have an A and this term doesn't have a B. Okay, and I'm just going to take the positive 66 out. This one doesn't have a negative sign and this one doesn't have a negative sign. So really what I could do is I could take out, if I was going to be really, really accurate here, I could take out a -1 on that one, and I could take out a, squish it in here, a -1 on that one, and you can see that the -1 is not common here, so I can't take it out. So I'll just take out the positive 66. All right? All right. All right. So here, well, let's just do this one. Boy, this one's so simple. There's no need to even write. Between the 12 and the 4, the biggest number that divides into those evenly at the same time is a 4, right? 12 divided by 4 is 3, 4 divided by 4 is 1. And I'm going to take out the lowest powered variable. Okay, I have 2 here and I have 1 there. Remember, 4x is the same as 4 times x to the first power. What's wrong with that? Factor. What's wrong with 4x? To factor this expression, write the answer as a product of this common factor. Look for variables. How could that not be right? I don't know. Okay, so they don't want that. Okay, here, sorry, I had to pause it for a second. They don't want the GCF. They want us to factor it. Hello, Simone. I gotta get rid of all this. I've got way too much in here. All right. Okay, not a problem. So, my problem changed from a x to a y. Okay, so the first thing that you're going to need to do is find your GCF, which again, between a 12 and a 4 is 4. Between a y squared and a y to the first power is y. Okay, that's where we stopped last time. Now to factor, what we're going to do is we're going to divide each term by this GCF. Okay, so the GCF goes here. And then each term gets divided by the GCF to see what's left. So 12 divided by 4 is 3. Y squared divided by y to the first power is y. And a positive 4 divided by 4 is a positive 1. And y to the first divided by y to the first is 1, so I have nothing left there but a 1. So now I'm going to redistribute, remultiply to see if I've changed anything. So 4 times 3 is 12, y times y is y squared, and redistribute again. 4 times 1 is 4, and the y. Do you see how what we're doing is we're just breaking this apart? So on a test, you want to redistribute. Okay? So to factor means, first of all, find your GCF and then divide through by your GCF. So let's fix this one, shall we? What do we have here? We have, I can't see. We have, I have to redeem myself here, 4y, 3y plus 1. So much for me reading the directions, huh? Do you guys do that too when you're on a roll? Sometimes I forget to look at what the directions are, like the last 3 were GCFs, and then I just still look for the GCF. So, all right, let's read the directions. Factor out the greatest common factor or a negative common factor if the coefficient of the term of the greatest degree is negative. Well, okay, okay, first of all, let's decide that. Which degree is the greatest? Well, a 6 is greater than a 5, so this whole term is bigger. Okay? Coefficient means the number in front of the variable, so that would be this negative 50. So is the coefficient of the greatest term negative? Yes, so I'll take out a negative whatever is common. All right, so again, I've gone down to the bottom without realizing it. All right, let's do this. Okay, I'm going to put my GCF here, and then whatever's left goes here. So between a 50 and a 5, I know a 5 goes into both of those, and it told me to take out the negative. So I'm going to take out a negative 5. Between an x to the 6th and an x to the 5th, remember, I take out the lowest power. Then I divide through by that GCF, both terms. So negative 50 divided by negative 5 is a positive 10. X to the 6th divided by x to the 5th is x. Negative 5 divided by negative 5, or I could say negative 5x to the 5th divided by negative 5x to the 5th. All of this is 1. All right, so that's just plus 1. Okay, so redistribute. Negative 5 times positive 10 gives me that negative 50. I've got an x to the 5th times, here, let's put the 1 on here, x to the 1st for x to the 6th. And then I've got a negative 5x to the 5th here. All right? So you're going to always want to redistribute to see, have I changed the original? I'm not changing it, I'm just changing the way it looks. Same thing here. We should probably do one of these 3-parters here. We haven't done one of those. 18x cubed minus 12x squared plus 6x. All right, so we're going to put the GCF here, and we're going to see what's left. Between an 18, a 12, and a 6. Just disregard this negative for right now. Just look at the numbers. Okay? 18, 12, and 6. What's the biggest number that goes into all of those at the same time? Well, a 6 does, right? This goes in there 3 times, 2 times, 1 time. So we're going to take out a 6. What about my variables? I've got a 3, a 2, and a 1, so I'm going to take out 1. So each piece gets divided by 6x. And what's left is 18 divided by 6 is 3. These are all 1s down here. X cubed divided by x is x squared. Negative 12 divided by 6 is negative 2. X squared divided by x is x. And this is all just 1. And I've got a positive, so it's plus 1. Don't forget that last term. Don't just disregard it because it's gone. And then again, redistribute. Check. Do I have the same thing that I started out with? Here's my 18x cubed. Here's my negative 12x squared. Here's my 6x. Okay, so it doesn't matter how many terms you have here. All right. So same thing. Between a 5, a 30, and a 35, 5 goes in there. I've got 1x to take out. I've got 1y to take out because these are 1s. And then divide through to see what's left. Okay? All right, so now we're going to start looking more toward a method called grouping. All right, so I have two terms here. Here's one term, and here's another term. Okay, terms are always separated by pluses and minuses. Now this is multiplication. This is r times something plus t times something. And yes, I know the something has addition subtraction in there, but that's not what I'm talking about. I'm talking about this type. Okay, between these two terms, they have a b minus 3 in common, don't they? They both have a b minus 3 term. All right, so if that's my GCF, I'm going to divide through. I'm not changing anything. You see what's left. All right, b minus 3's are gone, so all that's left is the r. b minus 3's are gone, so I have a positive t left over. Okay? Same thing here. I've got a 8a minus 5 that's in common. Now did you notice that the outside pieces were what was left, the r plus the t? Same thing here, 7a4 plus 8, right? Isn't it, let's see, 7a4 plus 8, it's this one, right? Fantastic. All right. Okay. So now look at this. We have 1, 2, 3, 4 terms. So grouping, GCFs can be any amount of terms. There is nothing that, it's to me, grouping, when I recognize, oh, this is a grouping problem, okay, let's just go back. Like this, if I was to add these, I'd look at it and go, it's a mess. Anytime that it's a mess, this is a mess, right? It's a grouping, it's a GCF problem. Now, in difference to that, grouping problems are always 4 terms, and they always have nothing in common. I mean, look at this. Between a 3, a 1, a 21, and a 7, all that's common is a 1, right? Because this one doesn't have the 3 in it, so there's really no number other than 1 that's in common. And here I can't take out a m or an n because this term here doesn't have either one of them. So it has nothing in common. So then we have to do a method called grouping, where we group the front two and we group the back two separately. So what I'm trying to do is I'm trying to get it to look like this, and then I can finish it. So my goal is to turn my 4 terms into my 2 terms. Okay? So between just the front two, there is something in common, isn't there? Okay, between a 3 and a 1, well, there's nothing in common there, but between the m and the m, I can take out an m. I can't take out an n because there's no n here, but I can take out an m. I'm going to divide 3 by m. Okay, so here we have 3 plus, right? The m's are gone here, so all that's left is a 3, and we've got n. I'm going to do it again for this back piece. Between a 21 and a 7, I've got a 7 that's in common. I can't take out any n's because this one doesn't have any, so that's as far as I can go with my GCF. Divide through by 7. 21 divided by 7 is 3. 7's are gone here, so all I have left is n. So I went from 4 terms down to 2 terms. So that looks like those previous 2 problems. And the thing in the parentheses are always going to match. If they don't, then you either have to start rearranging so they do, or you've done it incorrectly. Otherwise, grouping won't work. So here I look at this and I say, well, I have a 3 plus n in common between these two terms. Okay? And remember, it's always these outside pieces that are left, m plus 7. So what I'm going to do is I'm going to redistribute. I'm going to refoil to see if I've got back. There's my 3m. There's a positive 21. There's a nm. And there's a 7n. Now, is it the same? Yes, it's not in the same order, but like, who cares, right? Addition is commutative. 2 plus 3 is 3 plus 2. So just check for terms and signs. I've got a positive 3n. I've got a positive 21. I've got a positive nm or mn. Again, multiplication is also commutative, so mn is the same as nm, right? 3 times 2 is 2 times 3. And I've got my positive 7n. Good job. Good job. All right. Let's try one of these with a negative in it. 8st plus 28t minus 10s minus 35. Okay, again, I've got 4 terms with nothing in common. These all have 2's in them, but this one doesn't. This has a 5 in it, but that one doesn't. This one doesn't have the s or the t, so nothing's in common. So I'll group these separately. Between an 8 and 28, I have a 4 that's in common, right? That's the biggest thing. And I also have no s's on this one, so I can't take out an s, but I can take out a t. So I'll divide through by 4t and 4t. 8 divided by 4 is 2. T's are gone, but I still have the s. Positive 28 divided by 4 is a positive 7, and my t's are gone. I'm going to do it again over here. Okay? Between a 10 and a 35, I have a 5 in common, right? I'm going to do this incorrectly on purpose to show you something. Between these two variables, I can't pull anything out, so I'm done. So I'm going to take out a positive 5. Right? Negative 10 divided by 5 is a negative 2s. And a negative 35 divided by a positive 5 is a negative 7. Now remember, I said that these two pieces have to match, and they don't. Right? So what if I took out instead a negative 5? What happens then? Make this a negative 5. Negative 10 divided by negative 5 gives me the positive 2s, and the negative 35 divided by the negative 5 gives me the positive 7, and now they match. So if they're not matching because of a sign, then just switch this sign, which switches all these signs. Now these have the 2s, that looks like a 5 again, plus 7 in common, right? And the outside pieces are what's left, 4t minus 5. Okay? Does it matter if the 4t minus 5 is on the back end? No, because again, multiplication is commutative. Remember, addition and multiplication can go either way. Subtraction and division cannot. Okay? Let's see, that one I think I'll leave you alone on. That's exactly the same. And let's see, x squared, yeah, that's the same too. So those are nothing different. Okay? So far what we've learned in this section is GCFs, and factor by grouping. Now we're going to use the factor by grouping in our trinomial work later in a section that's coming up. So don't forget how to do that. Now if you get to the AC method for the trinomials and you've forgotten your grouping, then just come back to this video and just watch you know, a few pieces or parts of it just to refresh your memory. Okay? So happy factoring!